Okay, I think we are live now, finally. So, hello everyone, and welcome to Memgraph Community Call. Today I have Daniel Davis and Mark Adams, founders of TrustGraph, with me. Thank you both for joining this Memgraph Community Call. It's really nice to have you here. I hope you're all doing fine. Yeah, let me get first a bit of introduction. So TrustGraph is fully agentic AI system for complex unstructured data. But today they are going to not only tell us a bit more about that and what they are doing on their side, they are also going to show us a demo. So the demo is on the topic of using AI agents to make sense of the UK law at scale. But also, what's maybe more important to Memgraph community is how Memgraph even fits into that story. Like, where is it? Like, do we have a GraphRAG? If there is a GraphRAG, where is Memgraph? And so on. So I think that it will be a really interesting one, especially because we have a lot of questions from the community members on how can I build an AI agent, how it can even interact with graphs and why, and what does it bring into the picture? Like, why is it even important? So I also would love to get a glimpse of Daniel's and Mark's view on this and how they see their product fitting into this whole AI world and kind of to share it with everyone and with the whole community. Yeah, Daniel, you go. Feel free to
Yeah,
say something.
yeah, that's a really great introduction to TrustGraph. And again, thanks for having us. Is we were looking into doing GraphRAG last year, quite early because of Mark's expertise and history with knowledge graphs and knowledge graphs at scale. Matter of fact, Mark's previous one of Mark's previous companies, Trust Networks, was built on a lot of knowledge graph tech, and that's actually where we met because Trust Networks was acquired by Lyft, and we went through the pre and post IPO at Lyft, which is another that could be a whole another webinar in its own. Um, but we were looking at building some GraphRAG. Well, GraphRAG is just being a part of a product we were building, and we realized, wow, this is actually a lot of work just to build this, to get this up and running, and get this up and running in a way that's going to scale for a product. And earlier this year, we kind of realized that that was kind of the most interesting thing about what we were trying to do was, the GraphRAG infrastructure. And when we started really committing to that, we realized, this is actually a little bit even harder than we thought. And none of the frameworks out there really helps you solve the problem. It's something that would scale up to a enterprise level product or even a consumer level product where you have, thousands, 10,000s, millions of concurrent users, where you have latency requirements, where you have reliability requirements, because, most everything in AI has been these very loose, code frameworks. I think at this point, the community, for instance, I don't think I'm saying anything unusual now when, people have kind of realized that a framework like LangChain is great for building a demo at a hackathon, or just a proof of concept that you can show somebody in a couple of days, but it was never really designed for scale and reliability. And now people are looking for ways to do that. And, that's kind of where that's really the genesis of TrustGraph. That's kind of the philosophy behind it, is being a total um, end-to-end infrastructure that you can deploy. Everything is fully containerized, and Mark can go into the details about um, how everything's designed and structured today that we're going to show everybody. And yes, it's going to be a totally live demo, despite the fact that some people think that's a really, really bad idea. I don't like to do it any other way. What are you shaking your head? Yes, we're doing it live. Um,
I'm
Mark
down
is
for
well,
not
that.
that sure.
No, it's
well,
all cool.
yeah,
I
um,
love
and
love the live demo.
well, I mean, I think that's actually a necessity in AI because, people want you to see, you typing it in to verify, is this a recording? Are you really doing this? I saw somebody from AWS, they did a demo where if you noticed in the top right hand corner, the time scale was going at about 2x, which um, which you realize, one, it's a recording, and two, it actually took way longer than this to actually
Yeah,
run this than what they're
it's not
showing
that
now.
fast.
Right. So uh, we're going to show it to you live, and fingers crossed. It should work. And Mark, I think, is going to do most of the driving for us. So that's kind of, my take on how TrustGraph came about. I don't, do you have a different take on that, Mark?
No, I think I guess we saw a lot of AI stuff that was just really unreliable. I actually developed a whole bunch of GraphRAG stuff, and then went to demo that. I'm a co-founder of Cheltenham Data Science Meetup, and I demoed some GraphRAG stuff there. And I used a bunch of other libraries, and after the demo, it all worked fine. I got it so that it produced the right result, and then it dumped a stack trace out on the screen. It was like I couldn't get that to go away. It's just like crazy. Why doesn't any of this stuff be reliable? Isn't
Yeah, thank you both for sharing your stories and intro to TrustGraph. I guess I'll leave the stage to you guys to share the presentation and to show the demo, and fingers crossed from my side as well. Yeah, if anyone has a question, I see you're already using a chat. You can post questions there or
Yes.
in the Q&A tab. We'll read them out loud during the presentation. So it will be
Hmm.
an interaction whole time, so feel free to ask anything. And I guess that's it. We can start.
Yeah, we would definitely prefer if you have questions to, if you see something and you don't understand what we're doing or why we did it, ask. We're going to do the best we can here. Mark is driving from the UK and I'm in San Francisco. So we'll see we'll see if we can keep this on rails. We
Good
do have
luck,
a
guys.
little, thank you. Let's see. Do you want to put up we do have a little bit of a short presentation just because, you have to, right? See, here's that driving part I was talking about. Cross the
Yeah,
pond
the fear,
driving.
it's just the speed is, if we had like 2x
Yeah.
now, it would be ideal.
Yeah. And he drives on the wrong side of the road too. I have to get used to that. But uh, you want to go to the next slide? Okay. Yeah, we kind of, as we alluded to, one of the problems we started looking at last year was safety engineering, which I have quite a bit of a background in that. And it's a domain where for instance, I had one time I was a standard that was 800 pages long, and each one of the criteria you had to comply with would reference other documents. And when you start going to those other documents, those could be 200 pages, 500 pages, 20 pages, 1,000 pages. And you realize that to understand the full scope of all the requirements, you are looking at tens of thousands of pages of complex technical information to understand. And not only did you need to understand it, you need to be able to understand how you could actually have conflicts between some of the standards with different interpretations, different requirements. And the truth is, no one person can understand all of that. And I would also argue that's one of the reasons why we haven't seen as much innovation in the aerospace industry over the last few decades, is because of this complexity of regulation. And people don't know how to deal with the complexity. And what happens when there's a lot of uncertainty? People become very risk averse and start saying no a lot. So we started looking into, well, can we use AI to try to understand, well, in this instance, looking at something like the NASA Challenger disaster, can we understand what went wrong with there? Next. So the first part of that problem is actually figuring out a way to, you know, ingest all these documents and being able to understand them into a different format. And, that's, not at all trivial. One thing that this some people are talking about a little bit and not as much as it probably deserves is chunking has a really big impact on the performance of these systems on um, kind of at all different levels. And that's actually part of the problem. One of the reasons I think we made a lot of the design choices too in TrustGraph is realizing that how do you design an infrastructure around if you have thousands of documents and you're splitting them all into chunks? How do you measure, how do you handle that situation? You have to have a very robust pipeline to be able to ingest all those documents, then be able to process all that. I know it wasn't that was a pretty big factor in your thinking, Mark, on the architecture of the infrastructure was the chunking process, wasn't it, Mark?
Yeah, I mean, there's quite a lot of. I mean, I guess you did a lot of analysis on the chunk size, and we kind of realised that one of the things that was quite important about the chunking was actually being able to get feedback and get some metrics, observability, and sort of people make decisions around the just like a fundamental factor like a chunk size. You'd think you could probably just pick a value and it should work for almost all the docs, but it seems like it depends on the topic you're dealing with. It's a very sensitive parameter.
Yeah, especially when it comes to LLMs, and I think if you're in this if you're in this webinar, you're probably in the camp of not believing long context windows do all the things that the big LLM providers say they do. And we actually have a post that we did a couple of months ago where we showed that chunking extremely small, as small as chunks that were 500 characters long, produced dramatically different results than even 1,000 characters. And these were with LLMs that are supposed to have 250,000 token context windows, million token context windows. And you would think that if you graphed a curve of extracted knowledge from chunk size, you would think it would be a straight line. And instead it basically did that. It started to level out around 4,000 tokens, interestingly, but ultra small made a huge difference. So go on to the next one. Right, okay. Which is really relevant to this topic. So one of the problems that we've seen most with using AI tech is not hallucination. There's a lot of techniques where you can improve the accuracy of the responses or at least guardrail a model so that it won't speculate. But the bigger problem is what happens when you miss information. And this is where a chunking pipeline and your extraction methodology is really, really critical. And it's another reason why TrustGraph is designed to kind of do a three-pronged extraction where we're focused not just on entities and relationships, but also topics. And the reason for that is that we found a lot of language models, if you just use the word entity, and even if you define it, it will not find conceptual topics. So you kind of have to differentiate between the two. Interestingly enough, though, there are a lot of models, especially smaller models, that can't understand the difference between an entity and a topic and will just extract the same exact list. But a good example of this problem is kind of the lost in the middle issue. And I made a video about this, which is up on our YouTube channel, where I was using Gemini 1.5 Flash to go through this exact report, the Rogers Commission's report that we were talking about. And I found that in the middle, there's all this testimony that the expert were giving to Congress. So there's like at page 90, there's lots of different names that are in the text. And I would find that Gemini would only find one of those names that was in that entire group in page 90. And I thought, well, why is that? And I actually scrolled to the bottom of the document and I realized that the 10 names that were given me were all at a list at the very end of the document. And I started rerunning the test and I found that when it came to extracting people, it would find a list that was at the introduction of the document and one that was at the end. But the stuff in the middle, it was just ignoring. And this was with a model whose advertised context window is 1 million tokens, and this was only using about 17% of that entire window. So you would think that would not be a problem. But it very, very much is, which necessitates chunking and preparing these in smaller and having a multi-pronged approach in how we extract this information.
Maybe a
You can go to the
question,
next.
Daniel, on that side. I
Oh,
saw a
okay.
couple of community members on Reddit asking like questions related to, okay, we had unlimited context window. Would that kind of move away the RAG thing? And I think this kind of relates to that.
Let's see. Are you utilizing LLMs? Yes. So we are using LLMs for the extraction process. Um, TrustGraph is what we call model agnostic. We support basically every single major LLM provider out there, including OLLAMA and Llama files if you want to run locally.
Oh, sorry,
Are you?
that's the polls. Just as sorry.
Oh, okay.
These are the polls. I was more asking in terms of so you can
Sorry
ignore
about
those.
that.
Yeah, no worries, no
What?
worries. It's a bit confusion. But I mean a good answer anyways. But regarding this context window
Hmm.
size and having it like if we were to say like LLMs will in the future maybe have this much larger, and some say okay if it's unlimited will we going to need RAG? And there are discussions like that on Reddit. I saw that.
I know, and I have seen zero evidence that anybody has improved long context window performance, and especially because um, a good point to. So let's think about it this way. So let's say the Rogers Commission report again. It's about 170,000 tokens, and we want to do an extraction on that. To do a really, really thorough extraction, we're probably, even if we're doing say 20% compression, we're talking about that would be 34,000 output tokens. Well, the maximum output tokens that Gemini will allow you is 8,000. So right there, that tells you it's not going to output everything that you need to know. And something that a lot of the some a phenomenon that gets overlooked a lot is that the models seem to be quite inconsistent on how much they will output. And what we found is that the output seems to be pretty consistent no matter how big the input is, which I think is
Hmm.
one of the reasons why when you chunk smaller, you end up getting a lot more information because you're just kind of getting the same amount of output no matter how much input you put in. I mean, if you look at the data that we got, it was astonishing how it was a really big increase. And so we were basically measuring how many graph edges are we extracting for a particular chunk. And I think it was about a 30% increase that using, a recursive, the LangChain recursive chunking method, which is honestly a very good method. I'm still not convinced that any of the more sophisticated chunking methods are really provide that much more value. Um, it and if you actually look at the edges, they seem legitimate. So and you think, and the problem is that when you do this individually, like say if you're just doing this in a Jupyter notebook and you're doing this one by one, you're not going to really notice because what it means is for every chunk you might get one more edge or two more edges. And 11 versus 12 you don't really notice, but when you have hundreds of chunks and it's consistent, every single one is that way, all of a sudden you realize it's quite a big difference. Let's move on to the next one because I know people want to see us live dangerously and with the demo, so we don't want
Yeah.
to we don't want to trundle this into the ground. Um, so again, that's kind of our philosophy in TrustGraph and how we extract entities and topics, and I guess the topics are entities as well. And we try to make connections between those through a three-part process. And it's a very simple schema. Mark, do you want to talk about how you've structured the schema?
Yeah, and I guess we're really using RDF technology here, so it's the same way
Stop with the
that
booing. Stop with the booing. No
I
booing.
know there's presumably a lot of property graph fans on here, but we're just doing stuff that kind of works. So we've got schema in the graph that describes types and labels and descriptions of things as well as the information itself.
And we can
It
move on
doesn't
to the
have
next.
to be done that way, but I guess it was just a convenient way to kick that off since we've got a few components that work with that kind of tech.
Well, I think that's one of the things we're going to talk about later is that kind of, I think what we're seeing is that with AI technology, we're getting a new way of working with these data sets and working with knowledge. Whereas, you know, ontologies and schema were very necessary when you need to be able to write queries. You need to know what the basic structure of the graph is to be able to write effective queries. Now we have techniques though where maybe you don't need to know exactly what's in the graph to be able to effectively query it. And if that's true, you know, would you structure the graph differently? And that's kind of some of the questions that we're diving into with TrustGraph. So move on. I think this pretty much, I think we've kind of addressed this one. You want to, yeah. Hmm. Guess, nothing new. Yeah. You want to keep going? This is kind of a rough architectural diagram of TrustGraph. I find so it's built on a Apache Pulsar, which is a pub sub backbone, and pub sub, if you're familiar with it, is pretty tricky to visualize. Even if you go to the Apache Pulsar website, they don't tend to do big graphics depictions of it either. It's a little hard to visualize. So what I tried to do here is I tried to describe a boundary in everything that's deployed locally within TrustGraph, that's in the containers and the few services that are outside of that boundary, like cloud LLM services are, of course, outside that boundary. If you deploy with Kubernetes to Google Cloud, that's, of course, outside the boundary. Also, Pinecone, if you use Pinecone, that's actually an API service now. I guess that's worth mentioning. Yeah. If you use that as a vector database, that's outside the boundary. But for the most part, everything is self-contained within that. And do you want to talk a little bit about why you chose Apache Pulsar and why you decided to go with PubSub for the infrastructure?
Yeah, that sort of really is in the arena of reliability. So I guess we saw there's a lot of folks doing amazing stuff with AI, but quite often you'd end up with a notebook with some Python stuff in it. And then the next question is like that's lovely. How do I get that into production? And so the process of going through, from prototype stuff to production, you quite often go through the same process as stuff like dealing with latency, dealing with scale. Something crashes, you don't want the user to see an error, you just want it to retry. And so, PubSub architecture is very friendly for building reliable stuff, scale up, retry things on error for you, and you have to worry about like a whole heap of stuff like that. So that's why we've chosen that tech.
Yeah, somebody was just asking a question about we kind of made a change on how we do the releases. As TrustGraph has grown in complexity, the one of the things that's actually on the to-do list is to kind of look at it a new way of not just releasing a flood of YAML files. So we actually have a config UI which enables you to build the configuration. Can you actually, yeah, can you actually pull that up and run through it real quick? That actually might be helpful.
Okay, so I guess relevant. Let's just skip ahead to this bit here. The graph store, we've got Memgraph in there as one of the options. That is that live, Daniel?
Is what live is that should be 18, that should be
Memgraph.
zero. Uh, oh, Memgraph Lab.
Memgraph. Yeah, Memgraph's in there as well. On that's in the
Yeah,
production version 0.17.
yeah, it should be. Yeah, I just put the link to the dev one, which was version 0. So we have two versions. We have what we would call the stable release, which is currently 0.17.16, and then there's kind of a latest release, which is 0.18.1, I believe. And so there's two URLs for that. But if you want to just quickly walk through this kind of shows all the configuration options where, the simplest way is to use Docker. We did like Podman, but I'm a little worried about Podman now that it's been donated to CNCF. I don't know how actively it's being maintained. If you want to go Kubernetes, Minikube, and if you want to really go Kubernetes, we can deploy to Google Cloud, which Mark has actually done for the demo, which we'll show. You're getting a lot of lag on this. Is that, or is that just my screen? There we go. So these are all the model deployment options. And for each one of these, for instance, if you choose any one of these, and if you scroll down, you'll actually see all the potential models available in those are there for you. Some of these lists need a little updating with a model. It's hard to keep up to date with all the different lists. And then you would go to the next page, which is kind of the customization page, which the data extraction prompts, this actually lists all the different prompts in the system. And it gives you the ability to customize those in each one. So I was talking about the three-pronged approach to how we actually do the data extraction. That would be the three that are extract definitions, extract relationships, extract topics. And if you click on any of those, you'll see the instructions on how they're actually structured, what they're actually doing. If you wanted to customize them, how you would go about doing that. And I guess the most other, okay, yeah, this is the actual query for how we're doing queries in the knowledge graph right now. And I suppose the other interesting one is the actual agent flow now, which is a React style agent flow. And this is kind of how, if you want to customize the general template for how the agent is working. And again, we're going through this sort of quickly. If you have any questions, let us know, and we can go through this in more detail. And for you'll notice in the agent flow, it's looking for tools. And if you go to this page, this is where you can actually customize the tools. And the tools available right now are the ability to query any information that's in the graph, or being able to do more basic text completion tasks based on parameters that you would pass to the agent. And this is instructions on, depending all the options you've chosen, you would click generate. That would actually generate the YAML file that you need with everything already pre-built in it. You would, and these are any of the instructions for maybe environment variables you would have to set. Like I said, if you choose a cloud LLM, of course, you'll have to have an API key. If you choose Pinecone, you'll have to have an API key. If you try to deploy in Vertex AI, that's a little bit more complex as well. Same thing with AWS Bedrock. You have two separate variables you'd have to set for that, and all that information will be set for you. So I guess what we should talk about now is that we had prepared for another demo. Mark had done an extraction on, let's see, quite a large amount of UK law for 2024, which I think you actually have running right now. Is that correct?
Yeah, that's right. I mean, it was from legislation gov UK, so you can just freely download this stuff. So it's all the legislation, primary legislation in the UK for 2024 year. It's kind of quite interesting. I mean, I guess legal, I guess we're all dealing with a lot of folks on this call are going to be interested in AI, natural language. Legal text isn't natural language, so I guess it is quite fun to see what an LLM makes of that. Legislation is quite interesting because it's quite linky. I mean, the stuff in the UK seems to be. I'm not a lawyer. I don't know much about it really, but there's a lot of internal references. There's acts are written that replace other acts or replace parts of, and there's sort of like the knowledge links internally are quite interesting to get your head around.
One of the reasons that people keep coming back to AI and law because it seems like it's a natural fit, and I want to talk about that seems part. We kept coming back to it because of in the US especially, cybersecurity has become very, very intertwined with the legal field because there's so much regulation, there's so many legal requirements that are around cybersecurity. So it seemed natural to really dive into this space. And that's one of the reasons why we've been looking into legal text for quite a while. So what Mark is really showing now is this is kind of a, well, this is a prototype of a UI that we're very much is in very much not even alpha testing, but it's kind of a new way of looking at and interacting with knowledge graphs, which is so do you want to pull up just to verify, Memgraph Lab so we can show that all the data is in there?
I mean, it might be easier just to show since we've
Okay.
got this on the screen. This is, I don't know, it's probably pretty obvious we're not UI developers. So if anybody's interested in joining the team who's got UI skills, get in touch. But yeah, so this is prototype here. It shows off some of the text. So we just did a query there that executed using the GraphRAG algorithm. It would have gone to the knowledge graph, extracted a bunch of facts that are relevant to the question, and done an LLM query against that. But I'm quite interested in the internal structure of the knowledge graph. I'm sure that most people aren't, because I'm just a bit like that. One of the things we've done is put a few nodes in the graph that helps to match that query there. So we can start to look inside what the graph looks like. This is pretty ugly to make sense of. It's probably easier to, this is the bit that I think works quite well, which is to present the internal structure of the knowledge graph. So we saw we had basically two edges here, two facts that are related to this topic here, and you can see that this particular whatever that is, it's part of the law, is the subject of this act. If I click on that, it'll start to expand, and it helps to see. Oh, don't let me down! Come on. Oh, there we
What
go.
did you pick
Right.
one that maybe is not
Oh,
connected to anything else?
I thought for a
but
second
looks
we were in
nice.
Oh, there it goes.
demo problem land, but no. So, if you've never seen a knowledge graph, then this is what it looks like. I mean, it does to me anyway. So you can kind of see, if I click on things, I clicked on United Kingdom there, and it sort of jumped into another bit of the graph. I don't know. This term amendment is possibly going to link to all sorts of things. There we go. So I don't know. It looks kind of cool. What we've got here is sort of a visual representation of the concepts that are processing, found inside the found inside the documents that we fed in, and it's built this graph automatically. It's done things like find out what the relationships are between bits of information. Digital activity is linked to United Kingdom. Okay, well, that's
Well,
probably not very.
there's a question that came up that I thought it would be good to answer. Do we use chain of thought? No. I don't think chain of thought, first of all, is a very effective technique with working for LLMs for a myriad of reasons. One, if we use chain of thoughts in the extraction process, it would take weeks, days to actually process. Um, Instead, that's kind of the design ethos around TrustGraph, is that we decompose these, I guess, for lack of a better word, these agents. I guess we have three knowledge extraction agents, for lack of a better word. We decompose each one of those into one task. And because of our architecture with Apache Pulsar, these are running in parallel. So, and Mark can probably go into more detail about this, or maybe even show some of this, is that when we ingest the document, it immediately gets split. It gets split into chunks, and then it gets sent to a queue. And these different agents are all subscribed to that queue. So they're going to pull that chunk off and do this processing in parallel. If you were relying on chain of thought, you would be having, how many LLM calls would you have for every single chunk, which would cause, like I said, the process to be incredibly slow and also incredibly costly. So for each chunk, it's just one LLM call. It's just one. For each chunk, each agent would be one LLM call. So essentially, for each chunk, you're getting three right now because we have three of the agents. But I don't even know that chain of thought would improve the extraction process, because I don't even see how that, I don't think that would even really improve it in any way. One of the things that we used to do is, it used to be necessary to get LLMs a lot of examples on how to do something, and we find that that's not necessary anymore. And what I find is that less is more with LLM prompts. The smaller you can get the prompt, the more concise, the more precise the language, um, much better performance you'll see. So no, I don't see now what you may be getting into is the concept of semantic chunking, which I know a lot of people, they think that that's one of the big performance improvements that's out there. I have not seen any evidence that semantic chunking really substantially improves the process. Matter of fact, there are a couple of tools out there that'll actually show you when you put in a text block, the different chunking algorithms, what it actually splits it into. And if you just look at the simple recursive text chunker, it tends to do a really good job because it's not just looking at characters, it's also looking for line breaks, and it prioritizes different line breaks differently. It actually does a really good job of splitting text into like paragraphs and splitting it cohesively. Um, so I don't I've not seen any evidence that these really complex chunking strategies and much more complex extraction strategies actually provide value that is commensurate with the extreme cost and performance increases that come along with those.
I guess since we got this on the screen, it's probably just that we sort of take a note about the scale of this. So we've probably got, that looks like about 100 graph edges on the screen there, I think, doesn't it? This particular data set is, I think it translated into about 140,000 graph embeddings and 20,000 graph edges. So that's the kind of
I thought it
size
was
of the
much
data.
larger. When I loaded, it's more like 150,000 edges, 190,000 nodes, something along those lines.
We've got a bigger legislation data set. I think that's what that was. This is
Oh,
just the
okay.
2024 bit. So, like, we find Memgraph works pretty well for this kind of stuff. You can see that, like, clicking on stuff, we get in real time response. So it's nice for data exploration.
When I think that's a good point to mention. Like, so when I load, so I have, I guess, a much larger set, which is about triple the size of this one. And when I load it in, for me, it takes about 30 minutes to fully load. That's how long it takes. And but do you recall what the extraction process, how long that was, Mark?
2 days, I think it was. It
So
was largely reliant on I'd given an LLM a bit of a beating, and it was quite a lot of yeah, yeah.
and that's one of the things that was also different about TrustGraph, which is a little hard to talk, which is hard to visualize, is what we call knowledge cores, so that we save the graph and the vector embeddings so that you can reload them into TrustGraph at any time. So that as Mark said, he spent 2 days doing this entire extraction process, and now he creates this core, which when you zip it, it gets down to about 20 meg, and he can text it to me, and I unzip it, and then I can load it in 30 minutes. I have all the same data as well. In terms of what was the most challenging part in terms of modeling what?
Probably maybe from unstructured to structured, kind of. I mean, I'm just guessing here.
Well, I can wait. I still need some
Yeah,
coffee. It's
yeah,
early for me. It's this is early in the morning for me. I think for everybody else, it's probably much later.
yeah, yeah. But maybe on my side, the question would
I
be, can
mean,
you shed some light on GraphRAG query as well? Like, what's actually happening in the background?
I guess what's happening here is, I guess, we show you what the prompt was. So this is the LLM prompt. It's a
Mm-hmm.
template, and we've just used an off-the-shelf templating, open source templating language. So there are two bits that get replaced. The first bit, it says there's a sort of system prompt there. It says here's the knowledge statements. That bit of template converts the knowledge graph into basically cipher format. So you've got the edge S predicate object. It's got round brackets around the round the S, square brackets round the verb, round brackets around the object. So there's, you know, standard cipher representation. LLMs understand knowledge graph formats. It's kind of interesting, but the cipher one seems to be the one that you get best results out of. And then the query gets fed in here. So the putting the prompt together was pretty straightforward for us.
Yeah, it's interesting. That actually goes back to an interesting problem on the GraphRAG side is how do you restructure the triples in a format that you can actually put back in for the LLM. And right now, we're actually just pulling it out as cipher. We find that the actual cipher notation seems to make sense for a knowledge graph, or excuse me, for most
Mm-hmm.
LLMs, whereas we got really mixed results trying to use RDF formats. It's really that could be its own topic of conversation is which RDF formats LLMs actually understand. And the short answer to that question is RDF XML and JSON LD, which are two of the ones that are the most, eyesores to the human. Unfortunately, the one that most people work with, Turtle, is the one that LLMs are the most inconsistent with understanding. But I did see a question talking about what are the most, challenges in the extraction process. I think the challenge is a lot of it around we designed TrustGraph to be use case agnostic at the moment. I mean, it's open source. It's designed with the intent that you're going to customize it for a particular use case, and we're trying to provide the tools so that you can do that. That being said, we know that for a particular use case, optimization around that. So just really simple instruction changes will yield big performance changes. I guess that's ultimately the challenges with the extraction is that very small changes in the prompt, which I really encourage people to never use with LLMs. Worry.
It's lagging a bit on my side. Mark is,
It's
yeah.
not. Is everybody still here?
Yeah, I think there's a lag problem on your end.
Yeah, yeah. Just a
There's an
sec.
Atlantic Ocean, I
Hello?
guess.
Yeah.
The fibers are getting a bit full. Is this a good point maybe to go and show people I guess the Memgraph? This is Memgraph Lab with some of our data in it. I think this reveals that we're probably not using Memgraph quite right. I think, so we're sort of loading this RDF data in it. So the objects could look like, so look at the schema. We're using a really simple schema. So as with RDF type stuff, things are either nodes or literals. So that's pretty simple. And then let's have a look. If I run that query, we're going to get. So what this is doing, this is using Memgraph's shortest. Is that gets a bunch of short paths between nodes. I'm saying, what's the relationship between the Secretary of State and the Home Office? I guess is sort of what that query is doing. I don't know. I'm not the best person at driving this UI, so I think I probably could have got this to do much nicer labels and stuff than I've got here.
Yeah, you can do it with like graph style editor above, so you can change also colors and that stuff. But yeah.
Yeah, I've seen that. It's a competence level on my end, nothing wrong with the interface.
Yeah.
So we've got Secretary of State is over here, and somewhere here is the Home Office. There it is. There's the Home Office. So I guess there's several paths going through this. So the Home Office is the subject of this ugly UID as a document, and then I guess the Secretary of State is mentioned in all those laws, something like that.
We have Daniel back, luckily.
Yeah.
Yeah,
So
sorry about
did it actually like hang right as I was saying don't use the word summary in your LLM prompts? The big
Yeah, we
LLM,
didn't hear that.
yeah, a big LLM obviously doesn't want me to tell you about this. So I think what I was saying is there's a couple of words that you want to be really careful in using, and one of those is summary. Because if you ask an LLM to summarize text, you're asking it to make value judgments about what's important.
Mhm.
And you don't know what's important in the document. That's the whole process. So that's, again, that's also a design tenet of TrustGraph is we don't know what's important in the documents that we're ingesting. So we're trying to ingest as much as possible, which means there's also a lot of noise. The extraction can be a little bit noisy. We do get, duplicates. We do get stuff that's not really important at all, which if you started customizing it for a particular use case, you could reduce some of that noise. But that's also one of the issues is that, again, if you don't really know what's important, you probably want to err on the side of extracting as much as possible. And then how you query the graph is kind of how you'll handle whether or not that's important or not. Another word to be really careful about using when you're extracting is fact, because you may not want only facts. For instance, law is a good example for that. If you're looking at, case law, what as a judge issue? A judge issues an opinion. So there's a lot of text in law that's not it's not fact, or the whole purpose is for a jury or a judge to determine if they believe it's a fact. So if you only ask a language model to extract facts, you can miss quite a bit of information. So our design philosophy is to err on the side of extracting as much information as possible. And then how we're able to extract that information is where we can determine the importance of it. And also, yeah, go ahead, Mark.
Yeah, I guess folks might be interested if you want to build your own sort of knowledge extraction stuff at scale, then there's something that's useful to do, which is to try and obviously scale it out across lots of different processes. So that means you can ingest stuff faster. But I guess the one thing you have to watch with that is that the if different processes are pulling different facts out for the same entity, there must be a way of making sure that you can align on those entities afterwards. So that could easily be a scale problem. But one of the techniques is just to make sure that if something fine, if we've got a processor that pulls out information on the Competition and Marketing Act, and Markets Act, then it can always use the same ID for that, regardless of where it gets produced in the chain, and then therefore all those edges fall neatly onto that node when it gets put together into a graph.
And I think one of the things that we've been really interested in looking into, and I've been looking into a lot, are a lot of the algorithms that are in Mage for Memgraph, using some of these more, analytical techniques for trying to understand, because we don't have this ontology associated with the graph, being able to use some of these analytical tools to understand, what are the most likely nodes in the set, what are the paths between those nodes, or if we can find the most likely nodes in the set, can we start clustering around them? And does that information right there give us a lot of information about the data set without even having to actually start writing the queries?
I think this primitive here, actually, the shortest path primitive, is part of the Mage library, I think.
It's actually built into Memgraph, so you run it just with Cypher. You don't need a Mage. We decided to put it right into Memgraph just to have the best performance for the deep path traversals, since it's also in memory, so it makes sense that it kind of does it best in terms of performance.
I thought was quite impressed with the performance of that one, because this is a very linky graph. There's a lot of the nodes have at least like 30 edges coming into them. So I'm kind of impressed that one clears through the system in 3 seconds. That's pretty cool.
Well, and I think that's an important point to make too, is that we designed TrustGraph to be as flexible and modular as possible, and which means that the tools are there, and we know there are ways to improve the extraction. If you want to tailor it for a particular use case, we know with just even some really simple changes in the prompts, just even simple changes in the system prompt, and that's another thing too, is that if you design for a particular LLM, we know that some LLMs, for instance, Anthropic now, they seem to prefer almost all of the extractions to be in the system prompt, whereas not in the actual prompt body. So just small changes like that, we know will improve the extraction process, and we have the tools to make those changes. But we also know that there's a lot of potential on how we actually query the graph. And once we know what we're looking for, if we know there's a topic that we're looking for, being able to use more sophisticated techniques to understand, are we looking for all the things that are most similar to it, or are we potentially looking for the farthest connection, the most anomalous connection that we can find through the most amount of degrees of separation that for a particular instance. So being able to tune for being able to understand what a user is asking for, and being able to start leveraging different types of queries within the system to build the prompts back for the generative side of the AI.
And I agree with you, Daniel, that kind of the most common issue nowadays is like everything is so use case specific. Like whatever you try to build each part of this pipeline, like knowledge graph extraction and then querying, and what you consider being like a relevant part that LLM needs to get, it's just kind of depends what you want to ask. Not even on the use case and on data set, but on what kind of questions are you even asking and you expect to get response from. There are different types of questions, so you need to be aware of what you're doing and what you're trying to achieve to even build a system like this to
Right.
work.
And I think something, and Mark said this earlier, and he said this to me a few days ago. He said that, well, legal text isn't really natural language. And I said, well, I'm still on the fence on whether I agree with that or not. I guess it depends on a perspective. But I said, if you're right, and it's really its own subset of language. We could say that about anything that's domain specific, like safety engineering has lots of terminology. Back in my aerospace days, one of the things I learned is when you work on one particular aerospace program, you have an entire language and set of terms. It's very unique to it, which means, is that natural language? Then we start getting into questions of like, what is natural language? Is it just conversational? And then when we get to these unique subsets of language, that they're their own, they're their own separate subsets of language. Being able to then mash all those together, well, the way I'm describing it, all of a sudden you're probably thinking, well, knowledge graphs are a very natural way of doing that, where we may have these subsets that are very domain specific that have to come together to kind of make sense of all this in a larger context.
Yeah, I mean, there are a lot of pieces to the puzzle, but we from Memgraph are definitely on the side of you need to kind of have everything in knowledge graph. I mean, not everything, but you need like having a knowledge graph would allow you to have that more context and to kind of have all your data connected in place. And kind of we think of it, is it like a additional brain of LLM to kind of understand all of the patterns, all of the relationships that are happening. And I think it's a really valuable work that you're doing out there to kind of allow to others to easily deploy these AI agents, having all those puzzle pieces. So thank you both for doing the work you're doing, and thank you for sharing this presentation. And demo survived, so I'm happy about that. Everything seemed to be working. I mean, you could have a chat and you showed everything in the lab, so kudos on that.
Yeah, were there any other questions that people had? Because I think also, interestingly enough, I actually had a conversation yesterday with Marco, the co-founder and CTO of Memgraph, and that podcast is going to go live in about 5 minutes on YouTube. If we want to drop the link down below, if you haven't gotten enough,
Yeah.
if you haven't got enough knowledge graph today, you can tune into that one. It's some really interesting topics, and Marco even weighs in on his thoughts on what AGI means and whether or not we'll ever achieve AGI. So you'll have to tune in for that one.
Yeah, definitely do that. I'm also looking forward to it. I wanted to see what you talked about. So yeah, I guess it will be a good one. I sent a link to YouTube in the chat, so please everyone check it out. And make sure to tune in. There will also be a live chat since it's a premiere, so you can ask questions there as well. And I think we can then wrap it up. There are no other questions. And I'd like to thank both Mark and Daniel for joining and having a wonderful discussion here about everything RAG related and AI agents related and all of the pieces of that pipeline that you need to do. And thank you for sharing your knowledge regarding that. And I hope we'll get to meet each other soon again, maybe on another topic. I mean, I see you have a lot of knowledge to share, so I would love to host another version of this.
Yeah, absolutely. We appreciate you giving us the time to talk about, and really excited about some of the potential that we can unlock with the features in Memgraph.
It's been
Looking
fun.
forward to
Thank you
that
so
as
much.
well. Yeah. To the whole Memgraph community, thank you for joining for another community call. We have holidays ahead of us, so I wish everyone really nice holidays. If you're going on a vacation, take a rest, enjoy it with your family, and we'll see each other in the January. We have a lot of new hot topics coming, and we'll kind of notify you about that soon. Thank you all, and see you soon. Bye.